Today's video is on integration using residues. In today's video, we are going to use the method of contour integration for solving integral minus infinity to plus infinity x square dx by x square plus a square into x square plus b square is equal to pi by a plus b, where a is a positive value and b is also a positive value. Now look here, there is a contour here, closed contour, so with center 0 and radius r. So this is nothing but a semicircle. The contour today I have taken is a semicircle with center 0 and radius r. See here, for solving this one, even though the video is lengthy, please try to understand. I have given a clear clarity for each and every step so that you can solve by your own, as this is a very important question. And now let us consider this integral. So this is in terms of x. I have transformed this in terms of z. That is z square dz by z square plus a square into z square plus b square is equal to integral c f of z into dz. So here I have given a clarity for contour. So where c is a contour consisting of a semicircle CR of radius R together with the real axis. So here, what is the contour here? Contour is a semicircle. Here the radius is R together with the real part from minus R to plus R. So if you observe this one, so this is a closed contour with the real axis from minus R to plus R, and next thing here is the semicircle CR. CR is with center 0 and radius R. Now the total integral c f of z dz will be from minus r to plus r. See here, from minus r to plus r, as this is the real axis, I have taken x here, f of x dx, plus this one, the semicircle, that is cr f of z into dz, where cr is a semicircle with center 0 and radius r. So from this, if you compare, so what is our f of z value? So this is integral and this is integral, this is dz and dz, and on comparing the middle terms, so f of z value will be z square by z square plus a square into z square plus b square. Clear? First of all, we have to find the poles for each and every function. So in order to find the poles for this function, so what we have to do? So we have to equate the denominator to 0. So what is the denominator of this? So the denominator is nothing but z square plus a square into this is z square plus b square is equal to 0. So this is z square plus a square is equal to 0, and here the thing is z square plus b square is equal to 0. So z square is equal to, this is minus a square. Here z square is equal to, this is minus b square. So z will be root over minus a square. So z is equal to root over, this is minus b square. So z is equal to, here if I cancel this one, so this will be plus or minus ai, and here the z value is equal to, this is plus or minus bi. So we are getting 4 poles here, that is plus ai minus ai, here plus bi and minus bi. So we have to check whether these poles are within the contour, on the contour, or outside the contour. So here, what is the contour here? So the contour is nothing but the semicircle. So this is the semicircle with center 0 and radius r. See here, this is the center 0 and radius r. So this is the real axis from minus r to plus r. So this is x-axis and this is exactly y-axis, and this is 0. See here, we have to plot this. So minus ai will be definitely here, minus ai, and plus ai will be definitely here inside. And see, and the next pole here is minus bi. So if you take this one as minus bi, and obviously it will be plus bi. So if you observe this one, so plus ai and plus bi are within the contour, and minus bi and minus ai are outside the contour. Now after plotting these ones, so we know the interior poles. The interior poles are plus ai and minus bi. So the poles here are z is equal to, this is plus ai comma plus bi are interior poles. So they are interior simple poles. So for these simple poles, what we have to find out? We have to find the residue. So for finding the residue at point C, the residue of f of z I am finding at the interior pole ai. So for this, so what is the formula? Limit z tends to ai, z minus ai into f of z. Clear? So this will be limit z tends to ai, So this is limit z tends to ai. This is z minus ai into f of z. So what is our f of z here? F of z is nothing but z square by z square plus a square by z square plus b square. Clear? So z square plus a square by z square plus b square. And now after cancelling this, I have to substitute the value of z as ai. So this will be limit z tends to ai. This is z minus ai, and here this can be written as z square by. This can be split into z plus ai into next one is z minus ai, and here this is z square plus b square. Now easily I can cancel this one and substitute ai in place of z. So this is ai whole square, and this value is ai plus this value is ai, and this is ai whole square plus this value is b square. So this is the residue value. So for this, the residue value will be, this is a square. So I square value is minus 1. So this value is 2ai. So I square value is minus 1. This is minus a square plus b square. Minus a square plus b square. So I can cancel 1a from this. So this is nothing but the residue value. So the residue value is minus a by, this value is 2a, and if I take minus common from this will be a square minus b square. Even I can cancel this one. So the residue value of f of z, see here, the residue value of f of z at point z is equal to ai value is equal to, this is a by 2i times of, this is a square minus b square. So this is equation number 1. So this is equation number 1 for the interior pole. For the interior pole ai, we got the residue value as a by 2i into a square minus b square. And the next thing here is the next interior value. So interior pole here. So what is the next interior pole? bi. So we have to find out the residue for bi. For finding the residue, see here, the residue of f of z for the interior pole z is equal to bi will be, this will be limit z tends to bi. This is z minus bi into f of z. Now, if I substitute all the values here, this will be limit z tends to bi, z minus bi into f of z. So, what is our f of z value here? So, f of z value will be, this is z square by z square plus a square into z square plus b square. So, z square by, this is z square plus a square into, this is z square plus b square. And now see here, this is limit z tends to bi. This value is z minus bi into z square by. So this can be written as z square plus a square into z square plus b square. If I split, this will be z plus bi, and this is z minus bi. So if I cancel these two and substitute the value of z as bi, this will be bi whole square by, this is bi square plus a square, and this is bi plus bi. See, this will be b square, and I square value, as you know that this value is minus 1. So this will be minus. So this is minus b square plus a square. This value is 2bi. 2bi. So this is minus b square by, so this is a square minus b square into 2bi. Clear? So if I cancel 1b, this will be minus b by 2i times of a square minus b square. So this is the residue value. So this is the residue value of f of z for the interior pole z is equal to bi. For the interior pole z is equal to bi, the residue value is this. So I am considering this as equation number 2. Equation number 2. Clear? So now after getting the residue values, so what we have to apply? Now we have to apply the residue theorem. So what does the residue theorem states? So this is the residue theorem. According to our residue theorem, we have integral C. This is f of z dz value is equal to, this is 2 pi I times of sum of the residues of the interior poles. This is a sum of the residues at interior poles. So this will be, see here, this value will be integral c. So this is integral c f of z dz value is equal to, this is 2 pi I times of sum of the residues at the interior poles. So this is the first interior pole ai. So this is a by 2i into, this is a square minus b square, and the second interior pole is bi. So this is minus b by 2i. So this is minus b by 2i into, this is a square minus b square. See here, this can be written as, this value is 2i. If I take 2i common from the denominator, this will be a by a square minus b square, and this is minus b by, this is a square minus b square. So if I cancel these two, so this will be pi by, this is a square minus b square. So here is a minus b. So if I split this, so this will be a minus b by, this is a plus b into, this is a minus b. If I cancel these two, what remains? So this is pi by a plus b. Clear? So this is nothing but integral c f of z into dz. Now here comes the problem. So here we have to consider this contour. So what is the closed contour here? So this is a semicircle. So with center 0, radius, so this is the radius r. So this is cr. So this is x-axis and this value is y-axis. So this is the total integral. So the total integral here we have to split as, so the total integral is from minus r to plus r. So this is minus r to plus r. So this is the closing. So this is minus r to plus r. So this is real axis f of x dx, plus here is the semicircle, that is the cr. This is f of z into dz value. Here we got as pi by a plus b. So this is equation some a. So this is equation a. So now as r tends to infinity, what happens? See here. As r tends to infinity, see what happens here. So this integral value, how it becomes. So as r tends to infinity, this will be minus infinity to plus infinity. This is f of x dx, plus this value is integral cr f of z into dz is again pi by a plus b. So I'll show you what happens to this as r tends to infinity. As r tends to infinity, so I am keeping z value as r into e power I theta. Clear? R into e power I theta. And see, the integral value is nothing but, so what is our f of z value? F of z value is nothing but, see here. So this is f of z is nothing but integral cr f of z is nothing but z square by, this is z square plus a square. So this is z square plus a square and this is z square plus b square. So this is going to become 0. So if it's going to become 0, if you put z is equal to r into e power I theta, I'll give it your clarity. Mod z is equal to r into mod e power I theta. See here, mod z value is equal to r into. So this is nothing but cos theta. Modulus of this value is cos theta plus I sin theta. As you know that mod z is equal to r times of, this is root over, this is cos square theta plus sin square theta. Clear? So mod z value is equal to r. So in place of z, I am going to write r. And see here, z is equal to what I have taken, r into e power I theta. If I make a derivative on both sides, then dz value is equal to r into, for e power I theta is again e power I theta, I into this value is d theta. So dz value is equal to r into, so this is nothing but cos theta plus I sin theta into I into d theta. So dz value is equal to r into, if I multiply with I, this is I cos theta minus this is sin theta into d theta. If I apply modulus, so this will be r times of, this is root over again cos square theta and this is minus sin theta whole square, and mod dz value is equal to, this is r into, the value here is d theta. So coming to this point, so here we have z square by, this is z square plus a square into z square plus b square. So this is a cr, as in place of r, So this is dz. So in place of r I am going to write, so in place of r I am going to write as z as r, and here this one dz as r into d theta. Clear? So I'll give you z as r. So this is r square. What is z? This is r into d theta. Here is r square. In place of z as r, this is a square, and this is r square plus b square. And see, we can write this as, so this will be r cube d theta by, this is r square, so this is r square. If I take r square common, this will be 1 plus a square by r square, and if I take r square common from this will be 1 plus b square by r square. Clear? So I can cancel 3 r's from the numerator as well as the denominator. See here, one r is left over. So here in the denominator there are 4 r's, and in the numerator there are 3 r's. As r tends to infinity, if I keep infinity, 1 by infinity value is equal to 0. Therefore, integral CR f of z value dz value is obviously 0. Clear? If I keep this as 0, I have given a clarity for this one. If after keeping this will be minus infinity to plus infinity. What is our f of x? F of x value is x square dx by, this is x square plus a square into x square plus b square plus 0 value is equal to, this is pi by a plus b. Clearly, so what is our question? Therefore, it is asked as minus infinity to plus infinity x square dx by, this is x square plus a square into, this is x square plus b square, value is nothing but pi by a plus b. So this is how we have to solve. Hope you all guys understand. If you really like, see here, if I explain you once again, so this is the question given and this is the closed contour. And first of all, we have to consider this semicircle with center 0 and radius r as a contour. And see, there will be two parts here from minus r to plus r, and next one here is a semicircle. After that, so we have to take f of z from this. After taking f of z as z square by z square in plus a square into z square plus b square. So we have to find the poles. For finding the poles, everybody knows that we have to equate the denominator to 0. After equating the denominator to 0, we got 4 poles as minus ai plus ai minus bi plus bi. So we have to plot whether they are inside or outside or within the given contour, and this is the contour, and the positive values are on the upper half, therefore they are interior poles, and these two are the exterior poles. Therefore, there is no need of finding the poles residues for this, and we have to find the residues for these two poles. So the first residue value for this value here is, for zi is this one, a by 2i into a square minus b square, and the second interior pole bi value here, the residue value is this one. So these are the two residue values, and after finding the residue values, what we have to do, so we have to place it in the denominator. So residue theorem, that is 2 pi I times of the first residue value of interior pole and the second residue value of the interior pole. So after cancelling these 2i, so this will be the answer. So here, what is the total integral? So the integral is divided into two parts, as from the real axis minus r to plus r, and cr f of z dz. So what happens to the cr? So if r tends to 0, so this is minus r to plus r becomes minus infinity to plus infinity. As r is tending to 0, so this is going to become a 0, and therefore if it's 0, see here, if I equate, this value will be pi by a square plus b square. So I have even explained you after taking z is equal to r into e power I theta. So clearly z is equal to r and dz is equal to r into d theta, and after substituting, 1 r remains as r is tending to infinity. So 1 by infinity value is 0. So clearly this is going to become 0. So after substituting 0 here, so we got the required answer, hence proved. Thank you so much for watching. If you really like, you know what to do, please pass it on to your friends and siblings, and definitely this is a damn sure question. Please take time to understand and practice. Definitely you can get a good score. Thank you so much.